Hello guys, welcome to part 5 of our tutorial series on using Arena for simulation. Today we're going to be taking a look at how to incorporate plots into your simulation so you can watch different parameters happen with relation to time. And then we're going to look at how to use the routing system which is available in the advanced transfer panel. If you don't have the advanced transfer panel, then you need to go back to one of my earlier videos where I do explain how to get these panels here. So what I've done is open up example 1 and let's go ahead and save it as example 6 because we're going to modify it here. So first let's take a look at how to make a plot. So what we want to do is find a parameter we're interested in, and this is a very simple system. This is about as simple as it can get, but we are going to make a plot of it. So something we may be interested in is how many parts come out of the machine here in this process module, but since this is such a simple system, it's going to be almost linear. So we're not going to get a lot of information out of that. Something that may vary a little more is how many entities are in the queue at a given time. So to get started, we're going to click the plot button up here on our toolbar, and we'll have this window come up. And now this is the sample area. So this is what it's going to look like approximately. The only thing that's going to be different, of course, is the data. That's why it says it's a sample. So first we need to add at least one data series. So click Add, and Series 1 pops up, and you can give that a name. And let's name it num in Q. That's perfectly fine. And then expression, this is actually what you're going to be looking at. So let's pull it down. I believe there is, let's see, part exit system, number in, create part number out. Okay, it's not in the pull down menu the one we want, so let's go to build expression. And right here you've got basic process variables. Let's go to Q, and we want to do current number in Q. So click that, and you'll notice that the expression changes down here to in Q, and then it's got in parentheses the queue we're interested in. You can change the queue here or manually type it. We've only got one queue, which is this one, and that's the one that put it in there. So that's exactly what we want. So hit OK. And the rest of this is mostly for looks, so you can change how the graph looks. The thing we're interested in changing, or the only parameter we're interested in changing that's left, is the draw mode for the line. The reason we want to change this is because when it's in point to point, it's like a normal line graph. And what this does is this kind of implies that, say at time 5, that the value is this value here, about 15, whereas that may not be necessarily true, because remember, we're working on a discrete event-based simulation here. So if you'll pull this down and change it to stairs, you'll notice that the graph looks quite a bit different. It looks like stairs here going up and down. And this is more accurate because it reflects each event happening in the simulation at any given time, and it reflects the change that happens at each event. Therefore, it's more accurate. While it's not closer to reality, it's closer to what we're actually, it's closer to the model we're making. So that's all you need to change for our data series. But let's go and look at the axes. And notice time is on the x-axis. And as far as I know, that's basically going to be always, for the most part. So you've got grid lines here. This is mainly making it look different. You can play around with that. The thing we are interested in is the scale. So what we're going to do is we're going to change it to 500, and this is in minutes, because if you'll recall, that's how long we were running our simulation for in example 1. And click somewhere else and it'll update. Now notice that our numbers become very jumbled here. The reason that is because our major increment is set to 10. So let's change it to 50. This is basically how many units are between each line. Click on some other button and it'll update. And you'll notice it's much nicer and neater. Then one other thing we want to change is right here under title. We want to change the visibility from false to true. And you'll notice that time shows up down here. So that way the person looking at this, or yourself, knows that this axis represents time. Next, we want to look at the left value for the y-axis. Notice you can have a right value, but as far as our expression goes, we don't have one, so no need to worry about that. So look at the left value properties, and we don't really know exactly how high this is going to get. I imagine probably not over 10, so let's change the maximum to 10, and the major increment can be 1 is fine. And notice it looks really bad here. That's because in the sample for some reason it doesn't quite update like the other axis did, so that's okay how that looks. You'll see when I place it out here it'll look better. You can leave those parameters the same, and then we want to change the title to where it shows, and notice it just says value right now. So we can change this, and let's change this to number in queue, or actually let's just put parts, because this represents a number of parts. And then where we'll actually put the number in queue is going to be in the title. So let's add a header, and from middle school or wherever, you always have to have a header, so you know what this is about. Of course, that's not necessarily like a law, but we're going to add it for this so we know what this is talking about. And notice you can change how it looks, how it's aligned, and so forth. And the text here, this is what it actually is going to say. So we're going to call this number in machine 1 queue. And notice I put machine 1 because here shortly we're going to add a second machine when we learn how to use routes. Alright, and then if you click on another box or whatever, it will update down here. So here's a preview. And the last thing here that you'll notice is there is a legend, even though there's only one entry. So a legend doesn't really do us any good when there's only one entry, so go to the Legend tab and uncheck Show Legend. So that way we have more room to actually show the data that's pertinent to what we're interested in. So hit OK. And notice when you come out here on the grid, your cursor has changed to a crosshair with a little plot next to it. So what you want to do is go and left click once, don't hold the button, and then move your mouse, and we're going to drag out where we want the plot. So let's make it about as wide as the modules here and make it fairly tall, however you want it. Maybe a little bit taller there. And then there you have your plot. And notice this starts at 0 here. It will scale as the events happen. So let's go ahead and run this. Let's give it a save, and then let's run it, make it as slow as we can, and let's keep an eye on the plot. And notice it begins to update. These are pretty close together, but you can see the change there. So notice that it goes up as it needs to. And it will plot until the end of the simulation, whereupon you can view it. So let's stop that. So now you know how the plot works. So let's take the plot And let's move it out of the way here. Now, if you recall, I think I talked about this in earlier videos. When you are simulating something on the computer, you want to get as close to reality as you possibly can. So that way, when you look at the statistics, they are as correct as possible. So, in light of that, if you think about the systems we've made so far, the entities move along these paths here. But when you go back and look at the different times it takes for things to happen, when these parts come in the machine into the system, it's like they just teleport into this machine, and then they teleport out of the system. Essentially, the system is the machine. It doesn't tell you anything about how the parts got there, how long it took them to get there, or how long it takes them to get out of the system. So we're going to fix that. Now we are going to assume that the parts go straight into this machine, and then we're going to add a second machine and they go straight out of that, and that's where our simulation ends. So remember, or think about it like this: whatever you're simulating, you have to have a boundary of what you want to actually simulate. So our boundary begins when the parts actually go into the machine or the queue for it, and when they come out of the second machine. So we want to delete this connection here, and let's move this over so we've got a little bit more space, and let's go to the advanced transfer panel here. Now what we want is we want to add a station, and basically what a station does is it adds a place for entities to travel to. Essentially, it's like an arrival area or a station. So let's put that there, and then we need our process. So let's head back to basic process. We need a process for our second machine. So I'm just going to drag all these in, and then we'll put in the parameters as we go. And then the last thing you need is a route module. What a route module does is it takes and sends an entity to a certain station. So let's connect. You want them to come out of the first machine and go to the first route, or the route module here, and then you want them to come out of the station into process 4, which we will update here shortly, and then out of the process to exit the machine or the system. Notice nothing is going into the station here. That's perfectly fine. This route module will handle how they get here. So this is a little different. You don't actually see the entities flow like you did before, but that's okay. Remember, this is all logic. This is logic based. This is not animation based. I'll get into how to animate these delays later. So what you've done here essentially is between these two, we're going to add a delay time. So our system that we're modeling here doesn't worry about how it gets here. It just worries about how long it takes. So there may be a human that just simply picking up the part and walking it over to the other machine, or it could be a conveyor belt. It can be any number of things. But when you use route, you don't actually take into account what it is or how many resources it takes to get it there. You just worry about how long it takes to get there, which sometimes is enough information to tell you what you need to know. So let's start with process 4 here. We'll call it machine 2 works on part. Standard type, sees delay release once again. And then we're going to add a resource, and we're going to call it machine 2. And it takes 1 to get the job done. Triangular delay is fine. Change it to minutes. And let's put in some sort of random numbers. Let's say 4 is the minimum, 8's the most likely value, and let's say 10 is the maximum. Hit OK, and that's all set. You get your queue there. And then let's rename this, or let's work on the parameters for this. Notice there is a name and a station name. Name is simply the name of the module here, while station name is the name of the station that's contained within that module. So that's what's going to be used in the logic. So you could name this anything you want. It doesn't have to match this, or it can match that. So let's call this station for machine 2, and then we'll actually name the station machine 2 station. It's either different, but that's okay. As far as everything else goes, we're going to leave it at default. Hit OK. Now we're going to go to our route module, and we're going to name this route to machine 2. Okay. And now we've got a route time here. So let's say it takes 30 seconds to get from this machine to this machine. And let's change that to seconds. And then the destination type is going to be based on a just simple station. And then the station should be in this pull down menu here, machine to station. That is assuming you already set it up as we did first. Hit OK, and now you're all set. So we can put our plot back up here where you can see it good. And let's run the system and see what happens. And it's a little fast, but notice that the entities are sort of popping over here. And I know I sort of talked about how it seemed like the entities were sort of teleporting around. I know it seems like that way with the animation, but if you understand the underlying logic, then you'll understand that this is sort of where they're being carried over to the other machine. So let's take a look at our results and let's see what's new. Alright, let's pull this down. Let's go to entity. Alright, now we've got a transfer time. Whereas before this was 0, now it's 0.5. So that's half a minute, which is 30 seconds, which is exactly what we set it to. So of course the average, if we set it as exactly 30 seconds, of course the average of 30 seconds is going to be 30 seconds. So you'll notice there's a value here. You can use different distributions to have random numbers of how long it takes. Say it's going to be random if a person carries it. Sometimes he might walk faster. He may get fatigued sometimes, and he may be distracted by another talking worker, whatever. That all comes from statistics and however you're modeling. But the 30 seconds shows up here. And it also adds to the total time, which is longer now that we have the transfer. So now you have a little more background on the different ways you can use some more logic here, as well as another tool to display your model, so you can have someone watch it and keep an eye on a certain parameter, or you yourself can. And I hope that you will explore these and go a little more in depth with them. This was a really simple overview. So I appreciate you watching, and hopefully this material was good for you. And I apologize for the delay on the videos. College does take a lot of time to get your work done, so I don't have time to make videos that often, but I finally got around to doing it. So I appreciate you joining me, and we'll see you next time.